Welcome to my presentation. In this presentation, let us see how we can solve example problems using the laws of exponents. In this example, let us say we want to simplify this particular expression. 3a to the power of 2, b to the power of negative 4. This whole thing is multiplied to another term, 4a to the power of negative 3 times b, close parenthesis. So the way we want to simplify these is by using the laws of exponents. So first things, we want to write all the similar looking terms together. So we'll write the coefficient term together first. 3 times 4, which is equal to 12. Then we have a to the power of 2, and then we have a to the power of negative 3. So since the bases are the same, we can write the base ones and then we can combine the powers. Therefore, we can write this as a to the power of negative 1. We can write this as 1 over a to the power of positive 1, or we can just write it out as 1 over a. Then the second term we have is b to the power of negative 4 times b. So since b to the power of negative 4, and then b means b to the power of 1, so we can write the base term once and then we can combine the exponential terms, negative 4 plus 1. So this is going to be, we can simplify that as b to the power of negative 3. Since we have a negative exponent in the numerator, we can write this out as a positive exponent by bringing it down to the denominator, 1 over b to the power of 3. So therefore, in step 2, we'll put all of these together and then we can write it out as 12, which is the coefficient term. The a term is 1 over a, and then the b term is 1 over b cubed. So putting all of this together, the numerator is 12 times 1, which will be 12, divided by a times b to the power of 3. And that is it. This is where we want to leave it. This is our answer. So we have used the laws of exponents to be able to simplify this particular expression. Let us apply the same concept and then see if we can apply the laws of exponents to another example. Let's say this time we want to simplify this particular expression. Open parenthesis, negative 7 x to the power of 2 y to the power of negative 5, close parenthesis, times negative x to the power of negative 2 y to the power of 7, close parenthesis. So we will use the exponential rules to be able to simplify these problems. As we have done in the previous example, we will write all the coefficient terms together, write all the x terms together, write all the y terms together, and then as a final answer, we'll put all of them together. So we have negative 7 multiplied to negative 1. The coefficient of negative x can be thought of as negative 1. The ones are implied. So negative times negative is a positive, 7 times 1 is a 7. So we have x terms, x to the power of 2 in the first part of the expression, and then x to the power of negative 2 in the second part of the expression. So we write the base term once and then add the exponential terms, 2 minus 2. So this becomes x to the power of 0. Whenever we have any term raised to the power of 0, that value is going to be equal to 1. Then we take the y terms, y to the power of negative 5 times y to the power of 7. Since the bases are the same, we write the base once and then we combine the exponential parts. So therefore, y to the power of negative 5 plus 7 is positive 2. So we have y to the power of 2. So therefore, in step 2, we will put all of these together and then write it out as 7 times 1 times y to the power of 2. Therefore, we can write it as 7 times 1 is 7, y to the power of 2 is, we can write it just next to that. Therefore, this is our answer. We have used the laws of exponents to be able to simplify this expression, and then we have arrived at this particular answer. So in our next presentation, we should look at some more examples and see how we can simplify these types of problems involving exponents, and then how we can solve them using the laws of exponents.